Today's lesson, we're going to start section 10.7 or 10.2, arithmetic series. We've talked about arithmetic sequences, and a sequence, remember, is just a set of numbers. Now we're going to find that series. In a series, we're going to take that sequence of numbers and add them together. So we're going to get a total. So in example 1, I just want to start by finding the sum of a set of numbers. So if I give you the first 10 integers, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and ask you for the sum of them, most of you would pull your calculator out, or your fingers, and start counting them up. 1 plus 2 plus 3, so on and so forth. But what we want to actually do is come up with maybe some kind of formula in some kind of manner that we can do this addition. Well, if I look at the sums, if I take my first term and my last term and add those together, I get 11. 2 plus 9 is going to give me 11. 3 and 8 is going to give me 11. 4 and 7 is going to give me 11. And 6 and 5 is going to give me 11. So if I add those together, 11 plus 11 plus 11 plus 11 plus 11, or 11 times 5, I end up with 55. What happened? Well, I added the first term and the last term, and that gave me the sum of all of each of my sums. Well, did that always work? Well, in example 2, if I give you the sum of the first 100 integers, does that work? So take a second, look at that, pause if you want, and go ahead and find those sums. See if you can't find some kind of pattern. Well, here I have 1 plus 100 gives me 101. 2 and 99 gives me 101. 3 and 98 gives me 101. And 101, 101. So it seems like I'm going to always be able to add up to 101. Well, how many 101s do I know that I have? Well, if we come up here, how many did we have? We had 1, 2, 3, 4. We had 5 11s. What do I notice about 5 11s? Well, 5 is half a 10, and I had 10 sets. Well, that always worked. So down here, what would I be adding together? Well, I'd add 49 to 51. Sorry, to 52. And then I'd be adding 50 to 51 to get my 101s. Well, how many then do I have? I'm going to end up with 50 of them. So again, that's going to be half of the total number I have. So my sum of a set of numbers of a arithmetic series is going to be the number of terms that I have divided by 2 times the first term plus the last term, or a sub 1 plus a sub n. So in this example, I'm going to end up with my n, which is 100. So the sum of the first 100 terms is 100 divided by 2 times my first term plus the last term. I'll go ahead and write that out as 1 plus the 100. Simplifying this, I end up with 50 times 101, or 5,050. And that would be the sum of the first 100 integers. So, a formula that we've got, and we just talked about, we kind of came up with. If I give you the sum of the first n integers, or n values of an arithmetic sequence or series, is going to be n over 2 times a sub 1 plus a sub n, where a sub 1 is our first term, a sub n is our last term, and n is the number of terms. Now what happens if maybe we just know the first term and the common difference? Well, we know that the nth term is the first term plus n minus 1 times that common difference from our previous lessons. So if I replace that a sub n with a sub 1 plus n minus 1 times d, it'll give us another equation, which may be useful if we know the first term and we know the common difference. So in example 3, we're going to now give a sigma notation. We know that n equals 1, and we're going from 1 to 7 of the function 3n plus 1. First thing we got to make sure is that it is an arithmetic series. Well, 3n plus 1 is linear, so that makes it arithmetic. Well, what do I know? I know that my first term is going to be plugging in my 1. So a sub 1 is going to equal 3 times 1 plus 1, or 4. I can also find my 7th term by plugging my 7 in, or a sub 7 is going to give me 3 times 7 plus 1. That gives me my last term, or 22. I also know how many terms I have. Remember, if we take the upper bound minus the lower bound plus 1, that's going to give me the number of terms. So 7 minus 1 plus 1 is going to give us 7. So now I can use my formula. So the sum of the first 7 terms of this sequence is going to be my number of terms, 7 over 2, times the first term plus the last term. Simplifying that out, I had 7 halves times 26. I would go ahead and divide your 26 by 2 to get 7 times 13. So we end up with 91 as our summation. And a couple more examples here. Example 4, we know that we're given the sigma notation again. Here, n equals 3 is our starting point, and we're going to go to 100 of 2n minus 3. Again, we know that it's arithmetic because it's a linear function. So I can find my first term. My first term in this case is a sub 3. Plugging my 3 in, we end up with 2 times 3 minus 3. So 2 times 3 gives me 6 minus 3, or 3. A sub 100 is going to give me, if I plug in 100, I get 2 times 100 minus 3. So I get 200 minus 3, or 197. My number of terms, well, I know my number of terms is going to be, again, 100 minus 3 plus 1. Remember, we always add that 1 to be able to figure out the number of terms that we have. So we have 97 plus 1 gives us 98. So the sum of our 98 terms that we're working with is going to be 98 divided by 2 times 3, our first term, plus 197. So again, the 98 terms added together gives us 98 over 2 times 3 plus 197 is 200. Again, 2 goes into 200 very nicely. So we have 98 times 100, or 9,800, as our first 98 terms of the summation. And finally, example 5, here we're looking for the 50th partial sum. Remember, when I ask you for the partial sum, that tells us how many terms that we're working with. So we know that we're working with 50 terms. If I look at 7, 12, 17, looking at the difference there, the common difference, it's going to be 5. So I know, again, it's going to be linear. I also know my common difference is 5, and I know my first term. Well, my first term was 7. So if I think about that, I could come up with the linear equation, and I could go ahead and figure out what the 50th term is to use that equation. But if you remember, and I'll put it back up here for a second, we came up with this other equation based off of the first term, the number of terms, and that common difference. So using that information, I can find the sum of this 50 terms by plugging in that information into that alternate equation. So I know that S of 50 is going to equal 50 divided by 2 times 2 times now my a sub 1, which is 7, plus n, which I have 50 terms in this case, minus 1 times my d value of 5. Now I can go ahead and figure this out. So s of 50, 50 divided by 2, that's pretty easy, 25. 2 times 7 gives me 14. 2 that we're going to add 50 minus 1, which is 49, and we'll multiply that by 5. At this point, I'd go ahead and throw it into my calculator. So I have 25 times the quantity of 14 plus 49 times 5, which gives me a total of 6,475. And this is going to allow us to find the sum of an arithmetic series.